Hey folks, welcome back to Advent of Code in F Sharp. We stopped at day 19 after part 1 because part 2 looked a bit more interesting. Needed a little think on that. And this is a short recap on how I solved part 2. Maybe let's dive into code directly. So the day 19 is called Aplenty, and it was the one with the workflows and the parts. And for part 1, we had to count the amount of accepted parts given our rule set here. And part 2 just said, just figure out how many of the infinite, or how many parts are actually accepted in general, not like a specific sublist. So we had to rework our algorithm a bit. And the way I did it was actually inspired by something I saw on the Reddit, the solutions mega thread. And this is this blog post by I'll link it in the description below, but this Xav does Advent of Code. He has great write-ups in Python. And the one thing I wanted to show was you could look at part 2 as some kind of a river, and every time you input, the input is not like a specific part anymore, but it's like a range of part criteria. For example, you start at the range containing every possible part, so every property ranging from 1 to 4,000, so that's everything. And every time you meet a choice, like a condition saying that, for example, whatever, x has to be smaller than 2,000, you split up your range into separate ranges. So one range where the x is smaller than 2,000 and the other range where the x is larger than or equal to 2,000. So you actually divide your river into two subparts, and then for every condition recursively, you slice that river into two ranges again, until at the end you have either an accept or a reject, and you just need to know the ranges that get accepted. And if you know a range that gets accepted, you can easily calculate the total amount of parts that are in that range. So this is the idea. It's a really elegant solution. And let's take a look at how I coded that up in F Sharp. So the first thing that changed is, instead of a part having integers, sorry, this is my part 1 code. So the first thing that changed is that I introduced an inclusive range. So it's a bit easier if you have an inclusive range. So end is included in the range, start as well. And instead of having a part specified by forints, we just have like a specification of a part range, which has these ranges. Everything else stays the same parsing wise and type wise, but the apply function that we had for part 1 that just would apply our workflow on a given part now works on the part with ranges. And if you take a look at the return type of apply, it's a part list. So you could just return the number of accepted parts, but I just return the ranges that are accepted. So that's why there's a part list. And if you know the return type for something like this, the rest of the changes you need to do follows quite naturally. So let's take a look at the apply function here. How do I do the river thing? So you see some things I have not used, I think, this year for Advent of Code, which you see here. Let rec and. This and keyword is something super weird. And this thing is called mutually recursive functions. So let rec is a way to define a recursive function. That's a function that can call itself recursively. And this AND word makes these two functions mutually recursive. This means that apply rules can call apply workflow, and vice versa, apply workflow can call apply rules recursively. So it's like a two-way recursion with more than one function. So this is this magical AND keyword you see here. So let's take a look at the main method, the apply workflow. Just does a lookup and applies the rules, because a workflow is a sequence of rules in my solution. You can look that up in part 1. So apply rules is where the meat of the matter is, and it takes a specification, so a range, and the workflows, and we just take a look at that rule. If the rule is a hard accept or a hard reject, we know what we have to do. Reject, we have no range that satisfies, so it's the empty list. If you have an accept, the input range is accepted, so that's a single element list containing the input range. Things get more interesting if we have conditions or just like, okay, now do the next rule. If we have do the next rule, we just call ourselves recursively, and this is why the mutual recursion is there, because I don't want to, I want to look up the workflow first and then apply the rules, and this is the apply rules function, so that's where the mutual recursion comes from. And then the interesting part, the splitting the river metaphor, as you would, is in here. So if we have a condition, we used to just have to evaluate the condition for part 1 to see whether or not we have to move into the branch. But for part 2, we just split our range into the true case and the false case. And this is what my little split function does. If you take a look at the return type, it takes a specification and a condition, and it returns a split. And a split is what you see here, this type. It just is a true range and a false range. So we split a range given a condition, and that's literally taking a look at which of the 4 criteria are we taking a look at, and is it less than or greater than some other operand, and according to that we just split our range. So it's an exhaustive pattern match on all the conditions and all the criteria. And if we have a split, we know the true part and the false part, and given that we can again do something. So if the condition just has like a hard-coded outcome, we just return the true part. A reject, we return nothing as before. So these branches, or actually this entire pattern match is a bit of duplication, I see now. But so yeah, it's the same principle. We also call ourselves recursively with the true part. And then for the false part, we just go to the next arm in this rule, in this workflow. So our workflow can contain multiple rules, and if it's a false, we have to go recursively to the next rule, or either even to the next, the catch-all at the end. So this is why you see an apply rules for the false bit. And if we know every range from the, in case this was true, and every range in case this was false, we can put those 2 ranges together in one big list of ranges. And that's all the ranges that will get accepted in the end. And that was part 2 actually. For the rest, it was just counting how many we have of those. So it's a really cool, really elegant twist on the problem. I liked it. This was day 19, part 2, and I hope to see you again for more Advent of Code in F#. Bye-bye.